Okay, this is the basic structure of operating system. These are the user application which are on the top of all this module. This is IO management, message interpreter, memory management, and process scheduling. Now process scheduling processes all the application programs, right? They give access of CPU to these applications. Now these applications may require memories, then IO, right? This block diagram also can be explained with the two different levels. One is user space and kernel space. In kernel space we have these modules, right? Where in user space we have different applications, user applications. In kernel space, the message interpreter forms a bridge between this IO management and memory management and process scheduling, right? This is the simple architecture of operating system. There are two types of operating system. The normal operating system, which is normally used in computer desktops and laptops, right? And a real-time operating systems. The basic purpose of a real-time operating system is to run industrial types of applications. Not the end limit, but normally we refer these operating systems in real time, and these real-time applications are required in industrial applications, right? The normal operating system is divided into two types of operating systems. One is CUI, Character User Interface Operating System, and Graphical User Interface Operating Systems. CUI type of operating system, if you know Linux operating system and DOS operating system, these two operating systems having a user interface with the character dialogues, right? The user continuously executes program through a dialog boxes. Okay, you just write the commands and executes the applications, whereas in graphical user interface we have a graphical representation of all the resources as well as all the application programs, right? You can also explore the different files exist in operating system over here. This is also applicable over here, but in CUI you need uh, to remember all those commands. Here you don't require to remember because all the shortcuts are available already, okay, as an interface. This is very easy user interface which becomes famous because of the usability and simplicity of as it uses graphical representation, whereas this is very difficult, and most of the programmer and developers, okay, they normally use these types of operating system. As already explained, CUI types of operating system, DOS, Unix, right? Those are based on the uh, character user interface. Graphical, we know Linux, graphical, Windows. Then we have iOS type of operating system. Now let's switch to real-time operating system because our basic aim is to understand what is RTOS, our practical based on RTOS, right? So real-time operating system, what for application they are developed, right? Real-time operating systems are the operating system which executes their functions, or right, in a time-bounded fashion, right? So each and every task runs within a time limit, right? The best example of real-time operating system is QNX, then we have VxWorks, then we have MuCOS2, then we have RT Linux, and so on. These real-time operating systems are different, far different than the normal operating system. In normal operating system, if the application requires more time, still that application runs and there is no hampered on the performance of the system, right? But in real-time operating system, if once the task fails to run within a task limit or task time, then it might happen the system may collapse or it may hamper the performance of whole system. So because of this, real-time operating systems are very critical compared to normal operating system. This is the general structure of RTOS. It's not complete, but there are certain changes in different types of real-time operating system, but this is generalized one. Okay? These are the applications, programs which are executing, right? There is a RTOS kernel where all the files and all the programs or operating system programs are placed. Then BSP, board support package, which execute this task or these modules, means different functions over the hardware. So BSP is nothing but a collection of hardware programs, means driver programs, okay, which executes different functions over the hardware. Now if application wants to executes, obviously it has to go through RTOS BSP and then it can access the hardware. In RT Linux, few of the applications can directly access the hardware through the BSPs. The best example of BSP is whatever you learn in your third year subject in under the MCA subject, like LCD driver, then motor driver. All these are nothing but driver programs which acts as a BSP, right? Board support package. So you developed a programs for a board, a development board, right? So if you write all the applications or programs based on the each and every hardware available on that board, then the collection of that software is called as BSP, board support package. This board support package supports RTOS to run on the hardware. Obviously, RTOS it helps application to run on hardware. Now, as we know, there are n number of applications which require this hardware. So RTOS schedules and synchronize each and every application to run on the hardware. This hardware may contain many resources such as memory, such as CPU, such as IO devices, okay, and these resources are accessed through the application with the help of RTOS and BSP. There are three types of real-time operating system according to their behavior. Soft real-time operating system, hard real-time operating system, and firm real-time operating system. The soft real-time operating system, as it's soft, that means if the deadlines is mismanaged or if the task require more time compared to scheduled time, then the system still perform all the operations without hampering. Performance may degrade, but in this soft real-time system, system never fails. Whereas in hard real-time system, if task exceeds the scheduled time or deadline, then the whole system may collapse. The best example is the aircraft Boeing 703 which collapsed, right? One of the system contains a bug, small programs contains bug which collapse the whole aircraft, right? Where many casualties happen, right? Now these systems are crucial and those are used in the applications where untolerated task execution should be happened. Informed real-time system, it has certain time constraint. They are not strict, right? And it may cause undesired effects. If the task requires more execution time, the performance may degrade, but the operating system never fails over there, right? And normally firm real-time systems are used in visual inspections in industry automations. That is the application. Working of real-time operating system, there are different types of functionality of RTOS. These are priority scheduler, then system clock routine, deterministic behavior, synchronization and messaging, RTOS services. Priority based scheduler, the scheduler prioritize all the tasks over the CPU, as CPU is the resource for all the tasks. Okay, so we need scheduler. So scheduler schedules different applications on the CPU to executes, right, runs, and to execute the whole process within a specific time. So this plays a major role in hard real-time system as well as soft real-time system. As we know, processes should must be executed within a stipulated time. These are the task states we already discussed. Ready to run means the task which are ready with all resources, they can be go to run. Run is the state where the task runs on the CPU. Okay, so CPU is engaged over here and the process gets executed if all the process is executed uninterruptedly. Block state, if process in running state interrupted by an resources, then it goes to block state where it wait for the resources to be free or to be allocated for that task, then only it goes to ready state and then it goes to run state. There are different schedulers available: cooperative scheduler, round robin scheduler, preemptive scheduler. Cooperative, where the mutual exclusion between the task or the subprograms. Okay, according to that, those tasks are runs on the CPU and the whole applications executes over the CPU. Round robin scheduling, a fixed time is available or fixed time is given to each task in a time division multiplexing manner. Preemptive scheduling, the preemptive scheduling involves priority time dependent time allocation. Okay, and there are 256 priority level as initially it is developed for 8-bit microcontroller, right? So 256 priorities are available nowadays. Priorities are according to the kernel design. Now priorities are more. There are some systems which supports more priority level and multiple tasks, as already explained, according to the new kernel which is designed. Now, in preemptive scheduling, uh, the it schedules a task according to the priorities, right? And those priorities may be changed at the time of application running, right? So the scheduling of each and every task is continuously changed, right? The best thing of preemptive scheduling is that if any task gets blocked, then it gets replaced with the new task, so that CPU utilization becomes more and the performance of the system increases. System clock, those provides a tick. Tick is nothing but a clock pulse. Okay, so system clock, so the whole system is quantified according to the system tick, right, which is derived by system clock, right? Interrupt routines are written uh, to run all the tasks concurrently, right? Concurrently means the task runs one by one fashion, but the execution looks like an concurrent execution, right? So in real-time operating system, many tasks those are run through interrupt routines. The delay latency or the latency period between the two tasks is very less. Deterministic behavior means uh, the system must perform complete operation as per the schedule or specifications, right? There should not be a more delay or more wait time for each task to run on the CPU. There are few messaging and synchronization techniques which are utilized in RTOS, like semaphores, event flags, mailboxes, pipes, message queues. Semaphore and event flags are used for synchronization so that task runs on the CPU, as well as to communicate among the tasks, they need mailboxes, pipes, or message queues. So these techniques, these functions are implemented in RTOS to make synchronization and messaging between the tasks.